Well, good afternoon, dear coworkers and everybody else who is watching this open session, and welcome. I think today we have quite interesting topic because we will, after a long time in open sessions, we will focus on uu5 and our user interface technology, and we are going to introduce you changes and improvements we implemented there, and we are going to show you how we are working on the next generation of this key component and key layer of our architecture. So the first thing, I will repeat what uu5 is, and after that Anya will take a deeper look into the new features and especially the new way how to implement components, because this is what the open session is today is about. And Martin Farkas will join us as well, and will you show some more patterns, and will you show the documentation and explain you in detail other things. So we hope that after seeing this open session and some self-study, you will be able to create new components with the way which is up to date and which is the default as we consider it now, because I must say that we changed a lot, and that we changed, and I hope we improved the way how components are implemented quite significantly. But on the other hand, there are some key assumptions, and let's repeat them. Put it there. So the first thing to say is still that uu5 and our architecture, which consists from the user interface, then from the application server which implements business logic, the persistence layer, applications or server-side logic, and the persistence layer. We have uu-cloud for simple deploying and operating applications in the cloud, and we have my territory and business territory to provide key business features to all of our applications in the architecture. And of course, I forgot to mention IoT, because we have a lot of nice IoT projects, both here in Unicorn University, because we are again transmitting from Unicorn University, and for example, our showcase. Okay, sorry for the short break. We had some technical issue, but hopefully it's solved. So again, uu5 is the library and the set of components, tools, documentation, online courses, and the production line for producing user interface, which is focused on all devices. It's implemented HTML, JavaScript, and cascading style sheets. And it implements the most important patterns and features, both from the UX perspective, like user interaction and data representation, etc., and from the technology perspective of view, so how you should implement the components, how the components should interact together, etc. This technology implements these patterns consistently, and the uu5 library itself is a basement for more than 200 other libraries which are now using this technology and tools to add more and more components. I will tell you the numbers later. Maybe you will be quite surprised how many components we already have. And so anywhere where I or the guys after me will be talking about uu5, we are thinking the whole user interface environment, not just the core uu5 library, because all those components follow the same patterns, the same architecture, and are composable together. By the way, how we compose components together dynamically, that we are able to use components from any applications in any other applications without previous knowledge and without previous compilation, that we are able to dynamically load the component on the fly and render it wherever it's possible. And the component can then contact its own server, get the data, represent the data, of course, if you have the appropriate access rights. It's quite a unique feature, which is one of the top things I've ever seen in the front-end technology ever. and wherever in the world. So I'm very proud of this. And there are many other features which are top-notch in this area. And when we are talking about the new generation, one of the key assumptions and key goal is to keep all those features and all those principles untouched, or to improve them, but keep the key idea and basically make it better. Better from the technology point of view, better from the productivity view, so we should be able to implement those components more easily, more faster, we should better test them, etc. So we have to be more performant, so we should keep the ideas and improve them. That's one of the goals we have to fulfill. And another feature I forgot to mention is uu5 string, because uu5 string is a templating, front-end templating language, which is like transpiled on the fly in the browser, and which allows you to compose those components dynamically and use it in editors and in other things, or by experienced power users. This is something unique to again, and it's not easily approachable other technologies. So these features are generic and they are not dependent on any particular technology as the ideas. But of course, we need to have some implementation, and the implementation of the current and upcoming generation is based on the library called React. Probably you all are familiar with React because it's the first and most used library for front-end developer anywhere in the internet. So I don't need to explain it too much. So we are still stuck to React, and we want to use React in the future. So this React features and React changes affect our implementation, of course. On the other hand, we have to find a ways how to keep our implementation and the ideas aligned with the features and with the principles of React, and not to lose anything. So one of the inputs we have to the next generation is the current amount of code which is already done. And we measured it yesterday with Sonia. Those are exact numbers because all the components which are usable and dynamically loadable are registered in a service called uu5 library registry. And we find out that currently we have 214 active libraries. And those libraries together have 2,996 components, so almost 3,000 reusable components. Any of them can be downloaded dynamically in any application and rendered. Those are just the reusable components. Then we have a lot of internal components which are as a part of the application. So roughly we have now, because we have 600, how much it was? 636 active sub-applications deployed in the new cloud right now. So if you count on average about 70 to 100 per one application of internal components, which we measured on, I think, seven representative applications, you will get a number like 40,000 components. So 3,000 reusable anywhere, and the rest is infrastructure, but still they are dependent on the architecture, on the current technology. 40,000. It's quite a lot of code. So when we want to make some changes and when we want to implement new features, because React did evolution, almost revolution, in the way how the components are implemented, one of the key inputs is that we can't have like a big bang approach. It's not possible to implement new generation and just to say, okay, now you have to re-implement all these 40,000 components. You have like 14 days to do it. It's not possible. From any perspective, it's not possible. So we have to find out how to integrate the existing components and how to allow to live the new generation along with the old generation, and that it's interoperable. So it means that new components can render existing components as children, that existing components which allow to input some children as an input can render new components, and that all the principles like level or nesting level and screen size and everything else is working regardless on which generation of component it is. Along with that, of course, we need to keep all the features and make them like working in both generations parallelly. That's another input. And with these patterns in mind, we want to use the most recent way and the most recommended way how the authors of React suggest that components should be implemented. Yeah. So, of course, you won't be surprised that we chose hooks, and the hooks are the most important part of the new way how to implement components. But on the other hand, to achieve the compatibility and interoperability, it took some time. Yeah. So it can't be we can't just say from day to day now we will switch to hooks because you will have new components which will not interoperate with anything. Yeah. So, but we get there, and you will see it later. So let's start with the changes React did and explain why the change is so radical. Because they try to present that it's just an evolution, but on the other hand, it's really a revolution. I remember when we were choosing in the beginning between React and Angular, that one of the reasons why we didn't opt for Angular was that at that time the current version was Angular version 1, and they just introduced Angular version 2, which was the only compatible thing was the name Angular. And everything else was different. Of course, the ideas and many other things, but from the implementation point of view, it wasn't compatible, and you have to re-implement everything or almost everything. Yeah. But React seems stable and keep the ideas and implementation aligned. But it was in the time where React even wasn't version 1; it was version 0.14. But they switched from 0.14 to version 15 directly. So, so the version naming shouldn't bother us because it was like a marketing decision. But in that time, there was a special factory which was creating React components called React.create class. And we based the component creation on this technology, and all our components were using this. There were a way how to use reusable logic called Mixins. It looked very well. It was very easy to reuse the logic between components, so we used them heavily. On the other hand, the implementation within React was so poor that the performance of such reusable logic and such components wasn't very good, and React itself abandoned this technology, although the 0.14 version was heavily dependent on them. So then came React 15, and in React 15, React said, forget about React create class, use standard JavaScript classes. Yeah. So the whole world was talking about JavaScript classes and that we should switch, and this was the standard. There were many questions from our coworkers when we will switch to classes. But implementation of classes in JavaScript, it's just a syntax sugar, and definitely it's not the major stream of JavaScript. Of course, with the exception of Node.js, because on the server side, classes make much more sense than on the front-end side. So I would say that the community never accepted this object syntax in JavaScript. One of the reasons is that JavaScript is by the nature a functional language. It's not an object-oriented language. It's prototype-based functional language. And the key features and key performance gains you can get is when you are using functional programming, not when you try to use functional programming to mimify object-oriented programming. And that's exactly what classes is trying to do, and that's why they have even some significant performance issues. So we were kind of waiting, and we weren't persuaded that it's really necessary to switch our React Create class to standard JavaScript classes because there was it was just different syntax, but no significant added value. And then in React, it should be in React 17, but maybe as you remember, React 17 should be gold on Christmas 2018, and it's almost Christmas 2020, and React 17 is still not yet released, and nobody knows where it will be. So maybe I would like to explain why. But they came with other thing, and they said, okay, let's forget about classes, because JavaScript is not an object-oriented language. Let's do it with functions, because the best thing you can do with JavaScript is to do functions. Everything is a function. Function is cheap, it's extremely easy to create it, extremely easy to destroy. it's blazing fast. So create a inline function is as fast as create a number or any other primitive. So you can work with functions heavily. And even in React 16 and before in React 15, there was a way how to create so-called function components. They were stateless, they were just rendering view according to props, and there was no lifecycle for it. So in React, like closing to 17, the team came with the implementation how you could introduce lifecycle and state to function components, and this is called hooks. And this is not just different syntax. This really brings significant performance improvements. And not only performance, the code is shorter, it's easy to read. Our current experience shows that it's quite easy to implement, and it's much easier to debug than the original lifecycle, so it tends to be less buggy. So we hope that when we use this syntax, our productivity will increase, and along with the performance of the applications. So that's something, you know. Before it was just syntax sugar and nothing else. Now we can get really some nice nice added value from switching the technology. So we are switching. I think I've already commented this. So we can go to another slides. By the way, I'm using these slides. They are from Reactive Conference where I was giving this presentation or something like this presentation in the autumn. And there were more than 600 people inside the room. So I hope sometimes the civilization will come back, that it's possible again. Yeah. It's nice to see you online, but unfortunately I don't see you. Yeah. So hooks, it's a new way, reinvented way how to share logic, stateful logic between components. The thing that Mixins tried to do, but it wasn't implemented well. But it seems that that hooks are Mixins which are done well, because they don't have significant performance or other issues, and they achieve really the goal that you can write once the logic and reuse it between components quite easily. Yeah. So I think that Onya and Farki will talk about it. So I don't want to go deeper into hooks. I will give this time to them, but there's another thing which changed very significantly between the versions of React. And that's the way how it manages rendering and how it manages lifecycle. Yeah. They don't mention it too much, but there is a complete change of paradigm. Yeah. Because still the state of the component, I mean what you see on the screen, is still dependent on props, state, and context, which was introduced in React 16 and before it was unofficial. But we are not talking about context today. We did some open sessions before. Yeah. But the changes in the way how you implement this state and how you change this state to something you can view and touch with your mouse or with your finger on the screen. So please scroll up, and let's start with some repetition. The original life cycle of React component was quite complex. Because the component starts with the mount. So the mount is when you first use the component, it's not in the browser, it's not visible. React creates an internal function or class or something, then it's projects this to the HTML. So it creates HTML elements within the browser, and that's the way how you see them. And anytime you interact with the component, it computes the state. It has like internal representation, which is called virtual DOM of the component. Then it compares the new state of the component of this virtual DOM with what is rendered in the browser and applies the differences. And it's doing again and again. Yeah. And there are some lifecycle methods like component will mount, which will be called before the first render. So it's something like constructor where you can initialize the component. But even before, there's a get initial state, which will give you the initial state of the component if the component is stateful. And after the first render, component mount lifecycle method is called, and then the components becomes to live. and it waits for some events, and when the events happen, what events it can be. It's like some user interaction with the component. It can be some event from the browser, from the environment, or some change of the tree of the components. So anytime something changes, there is like different way how to work with change of properties, another way how to work with change of state, and of course, another change may be that the parent component is destroying its content, so this component is dying, and there's another lifecycle method which allows you to like clean up after your component. For example, if you set some timer on the beginning on the mount of the component, this is the place where you should clean up the timer or anything which is persistent somewhere else that in the component itself. So this lifecycle is quite complex, and you can scroll down, but after that, with the class syntax, the lifecycle became even more complex, and there were first changes. Because one of the things which maybe show this blocks, avoid random wherever possible. This is important. Because one of the things why the lifecycle is so complex is the paradigm that before you call the render function, so you are manipulating with the content of the virtual DOM, you try to check the conditions if it's really necessary. So you compare new probes with the old probes, and if they are the same, you don't call render. You compare new state with the old state. If it's the same, don't call render. So you are still trying to find conditions and trying to avoid the render and do it before. Because the initial idea was that this will be faster. But the reality showed something opposite. It shown that it might be faster sometimes, and finally always, but in React 16 it was for sometimes. It may be faster to do the render and then immediately do another one. So for example, they removed will mount, will receive props, and will update lifecycle methods, and simply say, okay, render the component without initializing, then run the did mount, and on the did mount do the initial setup of the component, call set state, and re-render again. Which was in React 15, this was a pattern that we strongly advised against it. So now 2 renders in the beginning are okay, no problem, because it's quite fast, and it's maybe even faster than if you try to check before you start the first render that if the situation is right, and to start to initialize the component. And with the class syntax, some things weren't possible, which were possible before. And the class syntax bring another constructs like constructor. You probably know them from any other languages. So there was no need of initial state and will mount because because the constructor does almost the same. Unfortunately, because the awkward implementation of classes in JavaScript, it doesn't do exactly the same. So there has to be 2 functions in the beginning. There's a constructor, and there's another get derived state from props method, which are called in the mount of the component. And then you render. Of course, you check if the first render, if it's then you direct render. If it's not the first render, you try to check the conditions, like this should component update. So you compare those props and state and decide whether to render or not. And after that, again, you decide, was it the first render? Then I call component did mount method. Is there any other renderer? Then you will call component did update. There's some technical function before, we don't need to go into details. And then you are running and waiting for some event. And if you change states or props, you go back to get derived props from state from props, sorry. If you change context, you go directly to render. For unmount, you call unmount. And they're introduced error handling directly within component. So if there's an error in a child component during render, you can go to the special branch where you solve the error state, and where it's possible to render some alternative content for the error state. So it's even more difficult. Actually, it's very difficult. I don't want to use any rude word, but it's very difficult to explain, very difficult to implement, and very difficult to test all the ways how you can go through this diagram and all the alternative states. So what's the next step with hooks? Show it. Does it look much more simpler? You know where this pattern comes from? The pattern comes from actually the gaming software, because I think everybody of us has played some 3D game anytime, so you are familiar with it, like Unity engine or Unreal engine, and all those engines are working very quickly. So maybe first show the picture about the engines, not this one. Yeah, we will get to it, you know. But the diagram, how this picture come to living, this one, yeah. So any 3D engine works in the same way, and it's supported by hardware. So when you render the scene and you do some interaction, you get some event which changes the screen, you calculate the complete new screen, then you compare the new frame with the old frame and find a diff. And then you tell the hardware to apply this diff. Actually, the hardware helps you with comparing the screens and calculates the diff for you. That's why there are so many transistors in graphic cards. But you are doing this again and again, and even if the screen doesn't change, you still are calculating the new frames. You compare with the old frame, you find that the change is 0, so you apply this 0 to the screen, so you do nothing. And you do this like 60 times per second. At least 30, because otherwise you can't play that. So 60 times per second, you can do this now you can show the picture in something which is such a difficult, you know. Of course, The Witcher 3, my favorite game. But look at the screen. It's extremely complex environment. There are hundreds of thousands of objects which are rendered this way. So think about our website and our screen. If it's possible to render such a complex scene with so many objects 60 times per second, is it possible to render websites with hundreds of some squares and boxes like at least 30 times per second? Of course it is. So the engine which is behind React with hooks and the lifecycle says, don't try to avoid render. Render anytime, almost everywhere, and make the render fast. So you are rendering the component and you are entering the render function again and again on any change. And you run the render, then you have a lifecycle method which can apply some effects which are not directly in the render, which like did update and did mount, even in the documentation are mentioned as functions for applying side effects. So there's a use effect. Now you can show the simplified, no, not the first one, simplified diagram. So after the render, you do the effects. There doesn't need to be just one method. There can be many use effects methods you can call. And you, again, wait for some input, for some change from the environment, from the user, anywhere. And when this happens, you render again. So now you should make render fast. You don't avoid renders. And if you are doing in the render something which is like repeated and which is like heavy computing or something, or server calls, there are new tools introduced how to optimize this. So how to call it, for example, just on the first render which is mount, how to clean up after the last render which is unmount, but still you have use effect for just one method for doing it. So it's much simpler, it's much easier to test, and much easier to optimize. Actually, it's not as simple as I show it here. That's like the happy day scenario, because this use effect should be suitable for everything. But on the other hand, if you just use effect, all your side effects, which might affect how the component looks like, are done after the render. So simply you render something, then the use effect is asynchronously called, and if the result is changing the state of what you see, you render it again, and it might, for example, blink or something. So Actually, this function is split it into 2-1. Now we can go to the end. So you have use layout effect, which is done after the render, but it's guaranteed that it's done before actually browser takes the diff and applies it. So before the paint of the scene. Yeah? And after the paint of the scene, there is this use effect. And with those two methods, you can solve everything in the life cycle and with rendering with hooks. So it's easy. It is really much easier. But we don't need to go to technical details of the hooks, yeah, but see the change of the paradigm. In the beginning, we were trying to compute heavily the conditions and trying to avoid the render anytime it's possible. Yeah? So call render was the last option. Yeah? Now we end up with calling render again and again, like a first option. Yeah? So this is really a big change, and it's important that you understand this change if you want to work with hooks. Yeah? Because all the architecture of hooks, all the way how they are like conditionally called, how they are memoized and other things, relies on this, that you are calling render again and again, and that the call of the render is fast. And it's faster to call the function than to test the conditions if it should be called. Yeah? So if you think about it and if you understand this, and you should because you understand the games and how they work, so I hope this example will help you. It should help you to understand the architecture of hooks and the way how we implemented them into uu5 to keep all our features and to improve performance and productivity of what we do. Yeah, so now I will pass the word to Anya, but first some wrap up of my forward, short one. Okay, so we are working on uu5 generation 5, but because we had to solve the compatibility, we have to introduce the features which we are considering or implementing for generation 5 to generation 4. And we end up with the state that we introduced almost, or I would say all features. So even the generation 5, it's not gold and it's not even in beta at the moment. All the features which are meant to be there are already implemented and available in generation 4. Yeah. So you can start, and you should, because now it's a standard and we are pushing everybody to do it this way. You can start to implement your components using these patterns and these tools and this architecture style with generation 4. And such components which will use just these new things will be like, there will be zero refactoring when we'll be moving to generation 5. Yeah. Still, it will be possible to run generation 4 and generation 5 in one page, and the component will interoperate. On the other hand, if you will have a page where it's just generation 5 and just the components which are dependent on generation 5, the performance will be significantly faster, like 1 magnitude. We are sure because we have results of performance testing. Okay. So from now, hooks are the preferred way how you should implement front-end components, and we are preparing, we have finished the documentation. The course is on the way, so we will quickly give you the online course in course kit for it, and we are working on all the standards together with Vladimir, because this change is so important that he again start to develop front-end and check that if we are really doing right, and of course he had some significant improvements to it. But I think we are on the same page, so we can make it public now. So we expect that till Christmas we will release generation 5. Maybe not this Christmas. We will see if React 17 is there. I can guarantee that when React 17 is out, that uu5 will follow in 14 days. Yeah. And but you can use all the features and all the way how to implement component for generation 5 right now, because it's ready in generation 4, and that's important. And now let's go to details.
Okay, thank you, David, for your introduction. And now I will continue with component, and I will start with uu5 component as you know. you know that uu5 component is created by create component, a function from uu5 and this component has mixin. This component has always uu5 common base mixin, I'm sorry, and you use render, and inside of the render you return some elements. In this render you use this keyword this, and on this you have props, you have state, you have everything else. You have all other methods which you declare inside of this object. And if you use this syntax, it's a little performance issue because all these methods which is in base mixin or which is in this component, here is no method, but in the mixin there is a lot of methods. So all methods or each method is binded to this instance of the component. So not just for class, but for the instance of this component. So if you use welcome 2 times, there will be 2 times binded all methods of base mixin to the component. So it's pretty hard to for performance. And now if you use a functional component, which is almost new in React, but exactly it's new in uu5. There you can create component as you almost do as today, but you will import create component from uu5 hooks. Yeah, and difference there is that if you create component by this syntax or by this function, you cannot use mixins, and the props you have as an argument of the render method, So there is no this. Yeah? If you want to prepare some function, you can declare it inside of the render method, or you can declare it before the component. Yeah, but inside of the render, you haven't, you don't have any this. And because of there is no binding, this mount and this render of this component is very fast. So now some advantages and disadvantages of component with mixins and component and functional components. Component with mixins has slower mount, as I told you before, because there is a lot of bindings. Each instance and each component has to bind all its functions and all its methods, it's the same, to the instance. And all methods of the mixins should be, or it's also binded to the instance, because even if you don't need it, even if you don't use it, so these methods are binded. The render is slow too, as David told us, because there is a lot of conditions for the whole React lifecycle. So there is a lot of condition for if it's first render, if not, if it's did mount, or if it's some error, and so on. So for these issues and for a lot of more, component with mixins are deprecated for now. It is deprecated in React, and it is deprecated in uu5. Also in uu5. Next disadvantage is that component with mixin is hard to learn, because if you use mixin, or if you want to create some mixin, you have to keep in your memory that keep in mind that if you create some mixin and you add some method to the mixin, so method must be unique for all of mixins. So if you combine 2 mixins, there shouldn't be the same method with the same name. Yeah, so it's not so easy to declare their unique methods. And if you write component with Mixins, you have to use this, and you have to write more code. Yeah. And about advantages, if you write component with Mixins, there is automatically state, there is automatically lifecycle of the component, there is support for error boundaries. Yeah. And in functional component has quick mount, has quick render. As David said, you can call render and render again and again. And this way is supported and preferred by React team and whole React community. Functional components are very simple. It's just function, and if you use JavaScript, you use a lot of functions, so it's not new for you. So it's easy to learn, and it's simple to create code, and there is less code. But what about disadvantage? Functional component without hooks doesn't support state and doesn't support lifecycle, because this is some conditions and something more, and this is doing by hooks. And for now, functional component without hooks and even with hooks doesn't support error boundaries, but it's just temporary, and uu5 will support it soon. So it's about functional component and component with Mixin. It's a different. And now we are go to how to create a component. Each component what we already have, each component has some tag name, which is some special or unique name for the component. And this tag name, what you know, we replace this name as display name, and this is name of the component. And if you debug your component in developer tools, in React developer tools, for example, there is 3 of the components, and there you can see the name or the display name of each component. So if display name of each component will be unique, you will find your component what you finding. And each component has to have prop types and default props. There is maybe one changes that today we are using get default props. For now, it's just default props. And we have 3 possibilities how to create component. We can create component with hooks. We can create component with Mixins, because sometimes we need it yet for now. And we can create component, high order component. If you create a component with hooks, it's the standard component as you should use for now. And you have several ways how to create it. You can create just component, or you can create a visual component. And you can create component with reference, what means that you can create interface of the component inside the building or inside of the component. But without ref, you can't to join your interface to some instance. Yeah. So component with ref and visual component with ref is only for component with interface, like method interface, not like props interface. And so visual component, what is different between visual component and just component? Just component has not any props, but visual component has a props what is standard for visual. For example, ID, for example, class name, style, disabled or hidden, and a parameter no index, and this parameter is just for searching. And so if you create visual component, you have to specify display name, what is unique. You can use or you can specify nesting level, and you specify prop type, default props, and in the render you will receive props, and inside of the render you don't use the keywords this, because this is not an instance of the component, or there is no binding, so this is unknown for this. And inside the render you can get all, if it's a visual component, you can get all attributes which you can use for the standard HTML element. So you just call uu5 command visual component get others, get attributes, set props, and set class name if you want to, and returned value from this function is object with ID, class name, style, disabled, and hidden, and all these props are HTML attributes, so you can pass it to HTML element or to another component, visual component, of course. And next step, you can check nesting level, so you will call nesting level get nesting level, set props, set statics, and current nesting level could be null or some value, and you can prepare some switch how the component should be displayed, or you can display some link with which open the component to the module, for example, like here. So this is visual component, and non-visual component is almost the same, but non-visual component is just component. This component does just some logic and render visual component. So it's easy. So next type of component is component with mixins, and component with mixins is not so obvious for now, but or it's very obvious now, but we have editable mixin and swipe mixin for now, and we have not any substitute for this, so it's necessary to use editable mixin and swipe mixin, but just for a short time, because we are preparing a substitute for it by hooks. So if you use mixins, you will call or you will import create visual component from uu5 not from uu5 hooks. Yeah, and here the structure is almost the same, but you can add mixins. Prop type, default props, and render is almost the same, but in the render there is no parameter props, but here you can use this. So as you know, for now you can use these props, you can use this state and something else. Everything else is the same as for hooks. And the last type of component is higher order component, and this component could be created by two types. One of these is for changing default props. So if you want to create a component and this component has just another default props or different default props than component that you use before, so you can create higher order component. This function is from uu5 and you just set it like before components. So display name, prop types, default props, and inside to the default props you can set another default as you want. And there is no render method, but there is just key component where you set a pointer or variable of the component, and you have to specify get props function where the props of the higher order component is received, and you can change it, and you can change, for example, that you set some margin to class name, or you can join some props from this higher order component to one component and set to covered component this one property, for example. Yeah, here you can change props. And the next type of higher order component is that you create a function, and inside to the function you send a component instance to the component or pointer to the component, so the variable of the component, and display name. And in this function, which has to start with keys with, or with keyword key with, sorry. So you return from this function new component. It should be not visual component, but it should be just component. And you set display name, you set prop types, default props, also the same settings as before. And in the render you have also props, because you use create component from hooks. So props in the render. And in the render you can use any component as you want for creating some logic or for showing some another components if the component is in some state. And if it's everything okay, you should return the component what is as a parameter from this function and add some added value to the component. In this case it's data, because loader loads data, so I set here the data. So this is 3 types of the component, how to create it. And now, if you have a component, you have some HTML which is rendered from the component, and you have to style the component. So for this styling, we have a new article which is cascading style in uu5. This article replaced another old one article, and this article shows us what is CSS in JS and how to use it in uu5. So we have 3 options how to use CSS. First is inline style. It's useful if you very often change the value for the style. For example, if you create some popover or some box which can you drag and drop to another place, so you always calculate the place where is the box. So there is possible to use inline style. Next is CSS file, and in CSS file there is a lot of functions. Sorry, not functions, but there is a lot of rows with styling, lot of classes, and with definitions, and not always are all of these classes useful. Sometimes you use just half of this definition of these class names and these styles. So if you bundle your library and there is a lot of codes, so it's big pain for performance and for mounting the library, for loading the library, because there is a lot of codes, and in some cases you never use some class names. So please don't use CSS files and use CSS in JS, what brings us to better things. Yeah, the first is that if you use CSS in JS, CSS are linked to the DOM, to the HTML, only when a component needs them. So if you have a lot of classes, you have just the functions, and if you use this function, use this CSS because you render the component which use it. So in this case, the CSS is inserted to the DOM, into the HTML, and to the memory too. And second thing is that if you write CSS in JavaScript, you can use all JavaScript support. You can use variables, You can use functions inside of the definitions of the styles, and it's pretty easier than learn some another technology like less or SAS. So why we do need CSS in JS? It's because we can generate less code, what has significant share on the loading of application, and it's easier to use because you can use JavaScript. Now CSS in JS, in CSS in uu5. If you use CSS in uu5, we have two rules. First is that CSS class has a random name. This point is because we have a lot of components for now, and this component has static class names. And another developer who use our component, so he override our styles because he use our class name and override the styles. So it's bad for component approach, because if you have a component, you have a props, and you have to change behavior and visual only by props. So by CSS in JS, we can change it, and all new components and all components in uu5 go5 will have just a random generated class names. So you can't override it. So this is the first point. And second point is that class is created only in the case when the component is rendered. As I told you before, only if you create component, if you render the component, its class is used, and it's rendered to HTML, and it's in memory. But if you don't use the component in one library, you can have, for example, 50 components, and each component can have about 10 classes. So if you don't use the component, all of its classes is not rendered, is not in memory, and doesn't or don't exist. So please create class names only in the render method. And then about syntax, at first you have to export or prepare somewhere in your application or in your library your module for CSS. This module could be exported from some file, and in this module there is prefix for your application or for your library. For example, here is for uu5. So each class name which will be generated will start with uu5 dash. And in uu5 we have, or not just in uu5, from this function there will be return object where is CSS method, join method, inject global, and keyframes method. And you can use all these methods for creating class names, or join more class names, or inject styles to global namespace, as you write before in, for example, CSS file. And you can create animations. So I will show you how to create it CSS. You can create it like, as you know, from CSS file. You write CSS apostrophe, and inside of the apostrophes you write CSS as you know, styles as you know. Yeah, but it's CSS in JavaScript, so you can use variables. Variables is written in dollar and brackets. Yeah, and from this for this row, there is a return value what is class name, and class name has generic name with prefix of the library. If you want to create a composition of these classes, you can use another classes inside of the classes, and all its settings or all its styles will be used. Or you can use a join method or join function and join two classes. It means that it's create new classes which contains rules or styles from both of the classes, and the styles are overridden in the order in which you set the class names to the function. Yeah, there could be a lot of class names, not just two. You can use it like text, as I showed you before in the apostrophes, or you can create it by object, and in object there is a key and value, as you know, and the result from this is the same, is CSS class name, a string with generate randomly name. So what about nested selectors? This CSS in JS support all nested selectors. You can use inner class name, for example, like this. Class name is here for icon, and I can use this class name with dot on the start. You can use media queries, you can use pseudo classes, or you can use pseudo elements too. And both is available in string notation and in object notation. And what about inject global, or what about global styles? You can set it also by the string or by the object. Yeah. And if you call this function, or if you call function CSS, in this moment the class name is created, and the class name is inserted into the DOM and into the memory, if you call it. And keyframes is almost the same as CSS or inject global. There is by string or by object you can create it. And how to use CSS in components? You have to be careful, because as I told you, if you call CSS and apostrophes, in this moment the class name is created. So if you create or if you create some constants before your component and call css.css, so if it's outside of the render, this class will be created immediately if your library is loaded or parsing or parsed. So you have to call as function, and this function must to be or has to be called inside of the render. Yeah, so I will call function as main, and I will call it inside of the render like this. And I can send there some props, and I can react on the props and show some styles. And it's possible for if you use a lot of if you use a few class names, you can write it into one document, or if you use a lot of class names, you can prepare it in the separate document and in the separate file, which is called like .css.js, and here you export it, and in the component you can import it like CSS, and there you can call like CSS main and attributes, or without attributes as you want. And it's all about styles. And now I will give a word to Martin, which show us hooks, and it's all.
I'm here, so thank you, Andrei. And David Kimmer introduced React hooks and how they boost performance of the components, and They allow us write reusable logic for components. Andre introduced functional components. They are needed for hooks and CSS in JS. What is new type? How to write CSS, and everything these changes are about performance, to have better performance for our components. And one of my goals today is introduce hooks in more detail and look under the hood. What is it? How can you use it? And how it is working behind it. So, first, I will return back to our article, Introduction to Hooks. First part, introduced by Andre, is about functional components, and second part is about hooks. And as you can see, there is a new section in uu5 documentation, hooks. And what are the hooks in uu5? Hooks are a new addition that is in uu5 since version 1.31. And it is based on React hooks. And what does it do? It lets you use state and other React features with functional components. And with hooks, you can have all advantages of functional components, such quick code, quick mount, quick render, and you can have this with state and lifecycle. In other words, you don't need to use Mixins for most of cases. And hooks are 100% compatible. What does it mean? You can write new components with hooks and combine these new components with old components written with Mixins, and everything will be working. Because uu5 team made great work and they prepared all principles and concepts supported by uu5 to hooks. Everything is ready, you can use it, and you should use it. We would like to write all new components with hooks. And what is a hook? We are talking about hooks today, 1 hour, I think. But what is a hook? And hook is only function from your point of view. And this function hooks to React features and allows you to have a function with state and lifecycle. In this case, for example, I will zoom it a little bit. We have a simple component, it is counter, and every counter needs at least one value, the count. And we are using new type of components, functional component, and we import another function from hooks, useState. And useState is one of the hooks that allows you to have state in your component. And we are using it directly in a render method. And during first render, the initial value is used. 0 is initial value of our counter. And the function returns array. In this function returns array with two fields. First field is value of the state, and second field is setter. And we use one of the JavaScript feature, and we create local variables count and set count and directly assign the fields from array to our local variables. Then later we show actual value to the user, and there is a button. When user clicks on the button, we call setter with new value. And why setter? Because React need to know we want to change the value. We can't change value directly. It is very similar to this state and set state from components with Mixins. You need to use setter, then React know the change is required, and you sorry, and React trigger re-render of your component and all children. Okay, and how is it possible? Because it is simple function and it has state. What is under the hood? And it is very simple. We have another component, double counter, and in this component we are using use state for two values. You can separate with hooks. You can separate your state into multiple parts. It is one of advantages of hooks. And there is pillbox. Why? It is for better explanation of mechanism of the React. During first render, when the first use state is called, 0 is stored in memory in one slot of this box. Second use state has initial value 20, and it is stored to another slot in the pillbox, in the memory of your browser. And when the component is re-rendered, or when user clicks on the button, the render function is run, and use state loads actual value from first slot, and second use state loads value from second slot. And the order is very important in hooks, because it is the only relationship between your business logic, your code, and the memory. And it is a reason why there are two rules of hooks. And first rule is the hooks should be called only from component, only from uu5 components or custom hooks. As I show later, you can compose the built-in hooks to your custom hooks and create some more advanced reusable logic. And second rule of hooks is all hooks should be called on top level of render method. You can't use some conditions, loops, or call hooks from nested functions. You must call all hooks in same order during each render. These two simple rules are very important. Without them, the hooks are not working. And React is checking it during rendering. And when there is some change in count of hooks or type of hooks, it throws exception and application is not working. So be careful about it. And what hook is the function, and what hooks are in uu5 library. Current version supports all hooks from React library. It means basic hooks for work with state, effect, context, and additional hooks like use reducer for some advanced state. There are hooks for memorization and improving performance, and hooks to work with interfaces and references. And uu5 contains more than 15 own hooks to support principles and concepts of uu5 libraries. So you can find here hooks like use level, use session, or use LSI. And other libraries like uu+4u and others will contain custom hooks to support their business logic. And you are free to create your custom hooks in your products to create reusable logic that can be shared among other libraries or applications. Okay, every hook has a detailed description, detailed reference documentation. Andrzej will show later where is the documentation. I hope there will be time. And now I will talk a little bit about life cycle. As David introduced, there are changes in life cycle. There is image of life cycle of previous components with Mixins, as you can see, the life cycle is really difficult. There is a lot of functions that you must know. You must know order of the functions, what is the purpose, and know what of the functions you should use for your logic. Very often you need to write your logic to multiple functions, for example, did mount, did update, and it is not easy to write reusable logic for such life cycle. With hooks it is easier. Everything what you need to know is hook use state to be able to initialize your state during first render of the component. You need to know hook use effect that covers all combinations of component related to mounting, unmounting, and updating. So all side effects that should be run asynchronously after render are done by this hook. And you need to know hooks for memorization, at least use Memo and React.memo function to be able to implement some performance features that were done previously, for example, by should component update. Okay, you can read about mapping in this article, and with functional components and hooks, the game changes. We don't need Mixins for most of the cases, like error handling and editable Mixin, but uu5 team is working on this, and in future versions there will be some substitution for these Mixins. And as you can see, only error boundaries seems to be issue because React hooks doesn't support them, but uu5 team will prepare component that can be used anywhere you need to catch exceptions in your components. And state lifecycle with hooks, you can have it in functional components, and you can have it in better it is better than it is in components with Mixins. For example, state, you can write custom hooks where you can use built-in hooks and custom hooks from other libraries and prepare your own reusable logic. And it was really hard to do it with Mixins. You could write own Mixin, but there was really big chance your Mixin will be in collision with Mixins from framework or other libraries. But with hooks, it is no issue because all state, all side effects you write in your custom hooks are fully isolated. So your custom hook will not be in collision with custom hooks or other libraries, of other authors, other applications. So it is short introduction to hooks, and Ondřej will now introduce the most important hooks and the documentation, reference documentation of the hooks.
Thank you, Martin. And I will try to be faster now. So we have a lot of hooks, and the important one is the useState hook. As Martin showed you, useState has one parameter. It's initial value of the state, and the return value consists of two items. First is the value, and second is the setter. You can also, if you set some value, you can set the value like directly, or you can set it like a function where you receive actual value and you return the new value. It's because of the asynchronous process of the setting the state. And this is for useState all. It's not so hard, I hope. And the next useful hook is useEffect. As David showed you, useEffect is calling after some changes. For example, if you mount the component, or if you change props, or if you change state, or if you change context, if you change something, you can use you can call useEffect. And useEffect is defined like that you call useEffect and you set first parameter as function. So this function is called after all changes or after mount, and you have to set dependencies, or you can set dependencies because if you don't set the dependencies, this effect or this function will be called after each render. Yeah, and if you set some dependencies, it means that this function will be called after the changes inside of this array. So dependencies is array, and if you set empty array, as it's maybe sometimes, I'm sorry, if it's here, for example, and here. So yes, if you use useEffect, and if you set dependencies as here is one dependency as running, so after each render, if the running is changed, so this function is called. Yeah, and if you set empty array, it means that this function will be called after first render. So it's like this mount. If you, as I told you, if you set no dependencies, it means that the effect will be called after each render. So it's about useEffect, and inside to useEffect you can set, for example, loading data, some asynchronous operation like loading, or some setting intervals, or some registering some events to the DOM, for example. So it's useEffect. Next, quite important hook is useContext. UseContext react on the change of some provider which is under your component. So if I change some context, some provider is rendered and change its value. So this hook is called. So this component which use this hook is rendered, and inside of the render, this hook return the new value of the context. So here is a notation, and it's for this. And faster, useRef is just for creating, for example, instance variables. If you want to set some value, because for each render, in each render, you declare or create new variables. And if you want to have same instance of the variable, you have to use useRef, and inside of this you will prepare or create some instance variables which you can use in each render. And useMemo is for performing, is for better performance. So you can use Memo if you want to the same value, for example, same instance of the object. So if you set this value, this variable, to some property, and you want to set the same instance as before, you can use useMemo, and useMemo return to you always the same value as before if you don't change dependencies. And use callback is almost the same as use memo, but use callback return function, not object or string or number, but a function. And use memo and use callback is used for some hard operations. For example, if you do lot of changes for somewhere, and or you calculate a lot of numbers, or this operation is very hard for performance, so you should use callback, for example. Or if you return some result which is hard calculated, so you can use memo and recalculate this value only if some input parameters are changed. So for this example, for these situations, these hooks are used. And next hooks is from React, and it's not so often used, but in uu5 we create hooks. For example, use screen size, which return to you actual screen size from your screen, or you can set the screen size by screen size provider, and hook inside of this provider tree will return the value which is set in the props of the provider. Or you can use language provider and use language, and if you use language outside of some language provider, so language is took from default, or is taken from default from global environment. Use LSE, use LSE values, and we have a hook, for example, for use print, when you can try, for example, printing, and you can see that this component is with different styles because it's the hook use print. So you can show some component or not for printing. We have use session for getting identity and working with identity. We have hook use device, where you return or where you receive settings of the device. For example, browser name, platform, if has touch or not, if has pointer or not. Pointer is the mouse cursor. Orientation, if it's portrait or landscape, or is in headless mode or not. So this is some static, so just some static settings of your device. And you can use call and some hooks for loading data from the server or communicating with the server, but for these hooks will be another open session for the introduction to these hooks. So it's all from hooks from uu5. And Martin, could you continue? Yeah.
Thank you, Andrei. And last part, or not last, but this part will be about best practices. But before we move to best practices, I would like to introduce last part of Hooks topics, and it is our new Get Started tutorial. And when you open uu5 user guide, there is completely new tutorial, and everything we introduced today, functional components, hooks, and CSS in JS, everything is incorporated in this tutorial. I think it should be interesting for you. It consists from 19 lessons, and these lessons are tightly coupled because this tutorial will help you from prepare new application by DevKit prepare your first component, your first page, first row, to advanced components like list, forms in modal windows, and dynamic rendering. And after this tutorial, you should have something similar. You should have implemented something similar to our reference application. I hope most of you know it. It is uu5, our application used for courses. It's a simple database of jokes, and after this course you should be able to write similar application with list, details, modal windows, forms, etc. And if you are completely new to uu5, so you should definitely go through elementary examples. It was originally get started of the uu5, but the uu5 team took the elementary examples and converted them from Mixins to functional components with hooks. And what is good, on elementary examples you don't need some development environment in your laptop. Everything what you need is modern browser, and you can read and learn, run, and see the source code of elementary examples. And they contain step-by-step explanation of main idea of the uu5 framework, component approach. So if you are new in uu5, I really recommend the elementary examples, because after them the lessons will be, I think, you will have know-how to go through the following lessons and understand all topics to create your application. Okay. Next topic of today's open session are best practices. Software Factory and uu5 team collected some mistakes that are made very often in our products and written best practices. First practices are from uu5 team, and I will quickly go through them, introduce every one of them, what is the issue and how to solve it. Okay. We have functional components and hooks, and first issue is about Mixins. New components should not be written with Mixin if it isn't necessary. For example, you need editable Mixin, or for error handling we need Mixins. And but for most of the components you can use functional components, you can use hooks. uu5 team prepared this table which is mapping between Mixins and what you should use as substitute for the Mixin. So please read this mapping and try not to use Mixins in your components. Second issue is about performance. Very often we see in components method or functions that don't need to be in definition of the component. And these functions are not working with properties or state. In this case, in this example, it is function that is responsible to only format some date. And all these functions should be moved from definition of the component, and it should be defined as static functions or as function above the definition of the component. Because when you define such function in component, so it must be bound. It is performance issue. Or in functional components, it is created again and again during each render, and you don't want this. Okay, next mistake. We see a lot of unnecessary HTML elements in your components. I'm talking about elements like diff or span, and you are using them only to style your components or wrap your components, because render method of React requires you must return only one component, one root component from the render method, and you are very often using it to have one root element or one root component. So what is the solution? Use uu5 common fragment. It means empty element when you need to return more than one component from render method. This is technical component. It lives only in virtual DOM of the React, and it has no representation in the physical DOM of the browser. And when you use diff instead of it, the React must move this diff from virtual DOM to physical DOM, and every change in physical DOM of the browser is performance issue. Second, if you need to style components, very often you don't need it. So check some advanced CSS features like pseudo elements, flags. If you don't need to support Internet Explorer, you can try CSS Grid or Calc. Okay, next issue. Every component, uu5 component or your component, has some public interface. This public interface are properties or interface methods of the component. And in opposite, CSS styles of the component are not public, and it is internal thing of the component, what styles the component generates and use. And don't try to override these styles. Yes, of course, you can do it. CSS in browser can be rewritten when you know name of CSS class. But from authors of component, it is internal, and they can change it without increment of major version of the library or product. And your styles may be broken by it. So it is not correct way how to do it. You should use color schema and theming for such things. And if you need improve the component and support some behavior, visual behavior, so please send request to the team responsible for the component and discuss with them what you need. Another issue, when you are writing your components and you need some diff or span, so please try to avoid using uu5.bricks diff or span, because these components are, how to say, heavy. They use some mixins, and mixins mixins contains functions, it must be bound, and it is performance issue. So try to use simple HTML elements like diff, span, etc. Okay. Next topic is about visual components of uu5. Every visual component of uu5 should support a few properties. ID, class name, style, disabled, hidden, main attributes, and no index. No index is for full text search because some components should not be indexed because it does not make sense. So you can use it. And how to do it? How easily support these properties in your components? You can, in functional component with hooks, you can use our utility visual component get attributes, and when you call this component with properties, so it will do all the work. It prepare attributes that should be passed to root element or root component of your render method, and everything is done. You don't need to do, nothing more. For component with mixins, you can use component functions from base mixin, get main props to pass, or get main attributes. It depends if you pass the values to another uu5 component or to some basic React component. Okay. Very often we see that developers don't know we have the common namespace with a lot of utilities, and so please check the documentation. There is a lot of functions that you can use to format dates, strings, work with components, URL, uu5 string, and for example, very often you are using moment library and you are using it only to format the date, but moment is really powerful, but it is big, and when you don't need to work with time zones, for example, or some advanced functionality for dates, so everything what you need to format the date is in uu5 common tools. So please check it, go through the list of the functions, and I think most of the functionality what you need in your components is here. And if you have some idea what should be here, send a request to uu5 team, and I think they can prepare it for you. Okay, and last issue from uu5 best practice is about communication between components. The preferred types of communication between components are properties, context, and events. You should try to avoid usage of interface methods because the components should communicate with properties and events, and interface methods should be used only when it is necessary, for example, for modal windows or alert bus. And try to avoid pass data to component in other way that the properties. For example, you could try to load data directly in a render method from some external source. In this example, it is simulated by date, but for example, sometimes we see calling of backend from render methods, and it is really performance issue because calls to backend are asynchronous. You must wait for the response, and it totally kills your application. And the user see nothing because loading is not rendered, because loading is waiting for response from server. Okay. Second part of best practices is about uu5 tiles, because this library is used widely among our products, and we see very often these issues. First set of issues is about tile rendering. As you know, we use tiles to show huge amount of data. For example, you load 1,000 of items from server, and you need to show this list to user. And we use virtual rendering. uu5 tiles library is based on virtual rendering. You render only what the user can see for better performance. So you don't render whole 1,000 set of items, but you render only, for example, 10 items, because user can see only 10 tiles. And when the user render down or up, you need to quickly change the content of the tiles. It means you need to quickly destroy the previous components and create quickly new one. So the mounting of the tiles and unmounting must be really quick, and it means it must be as simple component as you can write. So first issue is we see, for example, you are putting modal window to each tile, and it is the issue because when you are mounting modal window, or when you are mounting the tile, you need to mount not only the tile but the modal new instance of modal component to each tile, and probably you don't need it because this modal is used only when the user clicks on something and he wants to see some detail. So the solution here is simple. You will render only one modal window next of the uu5 tile list and send handler to the tile, and when the user clicks on the tile, you handle it in the parent in the tile list, or where the tile list is rendered, and you use the one modal window that is prepared here. Another issue is very often you need to check, for example, user rights or compute something for the tiles, and this result of computation is same for all tiles. And again, you are sometimes computing it again and again in each tile if, for example, as shown here, the user has rights to edit everything in the tile list. And this computation, this result, these rights are same for all tiles, so why to compute it again and again? You can compute it once before you render the tile list and send this data, the result, to tile as property. It's same with styling. You don't need to prepare and compute CSS styles, the class names, for every tile when the styles are same for all tiles, or similar for, I think, for every tile. You can prepare it before you render tile list and pass the class names to every tile as property. And this is again same issue, consuming of the context. For example, you need some context information in every tile, state of application, for example, to decide if the tile should be red or blue or something, I don't know, it isn't important now. And you read context in every tile, you need to render consumer in every tile, check the info and decide what should happen. And it isn't necessary. You can read context once in the parent component that is responsible to render a whole tile list and pass the results to component, for example, in as class name or flag how the component, how the tile should be rendered. And my favorite, when you need data for tile, so you try to load them directly in the tile list. You are using data manager or use data in the tile, and it is not good. You should collect all data necessary for your tile list before you render the tile list. And because, as I mentioned, the mounting, unmounting must be really quick because the user is scrolling through list, finding what he needs. So please try to avoid loading data in tile list. Prepare everything before you show to user. Okay. Passing properties. As you know, tile list sends to tiles a lot of information. Of course, there are data, the business data, what should be shown in the tile list, but he sends you the information about tile list itself, what is row, column, and other information, context information that probably you don't need in the tile. So if it is possible, don't send them to your tile component, and because it will improve the performance and pure render pattern can be applied to your tile. And last is about ID. You should not set ID to the tile. And fix the height of a tile very quickly. Try to avoid create a tile list where every tile has different height, because tile list must first render it to memory to know what is the final state of each tile, to be able to compute everything, and then he must do second render to the physical DOM of the browser, so everything is slower than situation where every tile has same height. Okay, so please go through these two articles, read it carefully, check the solutions, and try to avoid this common mistake. And I will now pass word back to Ondřej, and he will introduce second generation of tile list.
Okay, thank you again, Martin. So, okay, I will navigate back to the uu5 library, documentation. And I will continue with tiles, GO2, and I will start with basic examples. We have new generation of the tile because we have some issues with tiles. It was performing issue, and we decided that we create new generation only with only hooks. Yeah, so new generation is only with hooks. And we have next issues, and it was that our tiles didn't support next features like flex tiles. So we created flex tiles, and because we need them. And if we created tiles GO2, we decided that all of features which is in flex tiles will be automatically inside of the tiles GO2, because it's really a great features. So uu5 tiles GO2 contains components like visual components like grid, list, drag and drop grid, and drag and drop list. And this is new generation also because we changed third-party library behind of these tiles from React virtualized to React window, because this library is pretty small against of React virtualized, and it's newest too. So this is the second point to create generation 2. First is hooks, and second is the new third-party library. And we use it in grid and in the list for virtualizing the rows or the grids. And we have another components for managing data. This is component controller, sorter bar, filter bar, bulk action bar, info bar, and action bar. And the controller is also provider, which keep all the data and all the changes of the data and all filters, all sorters, all selected data, and pass this data to the bars and to the visual components like grid or list. And we also have next advanced components or supported components, which can help us for rendering our customer tile bars or our custom buttons. For example, if you want to add some button for filter to the header, so you can add the button for the filter, which names, or for the bar container, it's named bar container bar, and all filters and all sorters and all bulk action bar, or all bars inside of the bar container will be automatically collapsible or expandable by this button, by click on this button. And this week we released the last version of the tiles, and it's 1.3. And in this release there will be new components. We can show on the components. I'm sorry, components is here. So we have not just controller, grid, list, and so on, but we released also view bar, view provider, and data controller, and a few weeks ago also columns provider, maybe 1 week ago, columns provider, and all these features are from FlexTiles. So today each functionality from FlexTiles is available in Tiles GO2, and you can use it, and you can use these tiles because this generation of the tile is half of the size of the first generation. What about source code? So it's about half less, and about faster, it's about half faster too. So it should be more faster and pretty small. So here is, for example, columns provider, and how you can select which columns should be visible on or not. We have view provider, where you can set views, and then you can change views. In the view there is filters, sorters, and columns which could be visible, or order of the columns is also in the view. And the data controller is for loading data and automatic loading more data and more data. So it's pretty easy to just set loader, like on load, to the data controller, and you load these jokes, and if you scroll inside of the grid or list, there is automatically loaded more and more jokes for this example. So this is support which you can use, and if you want to create your custom sorter bar or filter bar or action bar, it's available, because all these components from which sorter bar or action bar or filter bar are created is here. For example, item button, icon button, add button, search button, of course, or bar as the skeleton of the bar. So you can create everything what you want, and it's new in the Tiles GO2. It's the difference between Tiles GO1 and Tiles GO2, that you have more possibilities. So this is documentation of the components, and I will return to the user guide of the tiles, where we have for now 12 examples, basic examples, where you can learn how to use, for example, sorting, and how to use sorter bar, and what is possibilities for sorting, what is possibilities for searching, or for a custom header with button for showing or expanding bars, as you can see. So you can check it, and please use tiles Go2 instead of flex tiles and tiles Go1 if it's possible. So it's all from me, and now I give word to David to some conclusion.
Okay, so we are in the end. Time is gone, but it's not gone dramatically, so just a few words at the end. I think that you've seen that we are improving a lot, and that we integrated to uu5 all the features available and all the experience we have with the development. So there will be next open session coming quite soon, which will be focused on examples on how to really create some certain components, because now we are together with team of business territory and my territory, and with our evangelists and with Vladimir, we are implementing core components like basic info for territory and basic info for artifact, digital workspace, etc. So we are going to show you these examples because it's real code which will be used and which you will be using every day. So you will see how components which are using those coupons are made, and we will give you some better experience than, because today it was a lot of theory, so next time it will be a lot of practice. So hopefully we will do it till the end of August. I have to check with Radek because this was unplanned, and originally we planned that we will fit it into one open session, but from the time perspective it's not possible. And we will probably include some other features we are preparing, like a new layout with a new graphic design system, which our UX evangelists are working on, and many others. So look forward to it, and hopefully there will be again like 100 people following us online, and many more which will run this later. So thank you for your attention, and I hope it was interesting. If it was, write us some feedback, and we will keep you posted about the features. Bye.